Alright, introductions are in order. My name is Casey DeLorme. I'm an IT student at Rochester Institute of Technology, entering my 4th year. Today I'll be embarking on a riveting Zen adventure, sharing with you my success born from blood, sweat, and tears since March. In case I'm unclear, this is the start of my comprehensive Zen tutorial, where I will be covering the start to the finish, everything. Zen is a Type 1 hypervisor. It's going to run underneath everything, and it's going to give us a whole lot of cool options. My key objectives are to create a multimedia platform with graphics pass-through, and also networking with pfSense. So, pass-through requires IOMMU. In particular, I'm using Intel hardware, so it's going to be VTX and VTD. I do not recommend my video tutorial for production environments. It is purely for educational purposes. What I hope to accomplish with this video set is to turn a process that took me since March to perfect, to make it something that a casual technology enthusiast could accomplish in a weekend. Please do leave me feedback. I would be grateful for critiques, and I'm looking forward to taking requests in the future. So, right now, what I'm actually in is the UEFI BIOS of my system. So, I have an ASRock Z68 motherboard, Extreme 4 Gen 3. All of the hardware is fully compatible, so again, if you're looking for good consumer components, check it out. I do recommend that you check out my written guide if you haven't already. It has a lot more detail than what's going to be provided in these videos, as well as covering a number of important topics. As far as Zen, Zen is obviously the main system that we want to use, but we need to install our control operating system first, which will be Debian Wheezy. So, just a little bit of terminology for you. Zen refers to all virtual machines as domains, and even the control operating system will run as a virtual machine, and it will be called DOM0, or domain 0. Every other domain running on the system will be a DOM-U. So, let's get started. I'm going to configure the BIOS here. I wanted to show you that there's an option called Intel Virtualization Technology that's by default enabled. That is VTX. VTX is not IOMMU. It's the original set of tools that started being introduced. It's x86 virtualization. It needs to be turned on in addition to VTD, which is in my Northbridge configuration. Now, by default, these boards will use the graphics card if it's connected. So if you happen to be using a monitor and you plugged into the board because you're planning to pass through the card, you won't get any video. So I have to set it to onboard as the default. Now, since I'm going to be running this as a server, I want it to automatically power on for me if there's a loss of power. I'm going to be using ACHI. I do not recommend using RAID, and I don't recommend using the Marvel as bootable, because that'll just delay the process. I'm turning off things that aren't used or that I don't have, and I'm going to make it so it's easy to turn on the system. I'm turning off legacy USB 3.0 support because it will cause a problem with backup drives. If I have a backup drive plugged into the computer, when it tries to boot, it'll attempt to boot from the backup drive instead of the hard disk, and that creates problems. So obviously it was very confusing when I first ran into it. Apparently there's a dehumidifier function in my computer, so I'm going to turn that on too, because it's just interesting. I don't want it to boot from the network, so I'm turning that off. I'm looking to do EFI compatible ROMs, and I don't want failguard, because that will attempt to automatically reboot the system until it works, which it may not. So, now that we have that set, we're going to have to switch our inputs from HDMI to VGA, because I set it to onboard, and this will bring us to Debian Wheezy Installation. For the Debian Wheezy installation, my objectives include using the GPT partitioning table and a UEFI bootloader instead of the traditional and ancient MS-DOS and MBR. To use GPT, you're going to need to select Advanced Options and Expert Install, otherwise you cannot select the partition table when you get to manually selecting partitions. You are welcome to deviate, but do so at your own peril. You will need to arm yourself with a Debian Wheezy Beta 1 installation CD or newer, and the latest Ubuntu Live CD would be recommended. For the most part, we're just going to enter through all of the defaults, with very few exceptions. The exceptions obviously being username and passwords. Potentially, if you're going to be setting up anything special for your network, you might set something other than DHCP. I'll just be using DHCP since I'll be doing manually configuring the network later. Obviously, drive partitioning is where most of the work will come in, and we'll want to skip some options too. So. Okay, for the partitioning, we're going to be selecting manual. I'm going to be combining regular partitions with UEFI. So we're going to start by selecting our disk, and we're going to change the partition table to GPT from MS-DOS. Next, we're going to create a 256 megabyte partition twice. The reason for the 256 is I believe it's a default minimum for the FAT32 file system. And we're going to enter boot/EFI manually for the mounting point. And this is our EFI partition. Now, it doesn't have to be the first thing on the drive, but I make it so simply because it's easier to do it that way. And this is going to be our boot partition, which means we will want it to be set to bootable. Okay, and the remainder of the drive will be put to Logical Volume Manager because we'll be using that for everything else. So then we need to go to configure the Logical Volume Manager. We're going to create a volume group. I'm going to call it Zen. And we're going to use that third set of space that we had there. We're going to create a few logical volumes on Zen. First is going to be DOM0, which will be the operating system disk, and that's going to be 8 gigabytes. And I'm going to create another volume group, and I'm going to call that Home. Oh, wait, no, not volume group, I'm sorry. Logical volume. Now we're going to make swap first. Swap will be 2 gigabytes. I have a lot more RAM than that, but I'm not really worried about it because I have that much RAM. I'm not looking to make this a debug CD, or a debug disk. So we're making a logical volume called Home with 20 gigabytes of space. The reason I use logical volumes is to simplify storage for the main operating system and anything I will be putting on the system. So the reason I use 20 gigabytes for Home is because we're going to be compiling a bunch of utilities at a later point, and we will need plenty of space. The Linux kernel, for example, will take up at least 7 gigabytes of space. And Zen will take up at least 1 gigabyte. Okay, so now that we have that all set, we're going to move on. This should write all the data to the disks, or finish the partitioning for us, and then it'll install the OS. Now, this guide was originally written for command line only. However, it has been modified and tailored heavily to use the GUI environment inside the main system, because my original objective was not to operate like ESXi, which requires you to manage the whole system externally. I wanted to be able to do it from the computer that I was working with. So the control OS will have a GUI installed, but it won't be through the menu here. I'll be doing it afterwards, because if I do it through the menu here, it will take an additional 30 minutes, and it takes only 5 if I do it afterwards. Plus, the installation done through the defaults will install a number of utilities I will never use, wasting space on my system. So I apologize for the random amount of wait time that we're going to have in here. I may or may not fast forward it in the video, but this gives you a realistic sense of how long it'll take to actually set up. So. Okay, so we're going to select the default Linux kernel image. We will be compiling a kernel later so that we can enable certain features for PCI pass-through and just to make Zen a little bit more competent from the get-go without having to load modules after the system boots. We'll be building a lot of features into the system. I'm not really worried about stability in the simple fact that I'm using Debian Wheezy Beta as well as Zen 4.2, which is also kind of in beta. It's actually under its RC4 right now, I believe. So both systems are still under development. So the fact that I'm using them should already constitute instability. However, I can say that Debian Wheezy, since I've been using it all the way back in March, has been rock solid. So I'm really excited for the final release. Excuse me. Okay. So I'm actually more of a software person than a hardware person. I've been using Linux for 2 years prior to starting this project, and I almost never messed around with the hardware portion of things. I always was setting it up for web servers and just development testing. And so this project has really taught me a lot about how Linux operates in terms of how it mingles with hardware and just sets everything else up, and really a whole lot. I learned more in this past 6 months than I did in those 2 years. So I really recommend finding something you're passionate about, and just finding a project that you can work on. If you spend a few months fiddling with things you're totally unfamiliar with, you will learn a whole lot more than you ever thought possible. Obviously, this means my system has been kind of in and out in terms of use, which is unfortunate because it's a really nice system, but it's also because it's a really nice system that I chose to do virtualization. The Core i7 processor, I barely even touch it. I could do all kinds of multimedia stuff on my system, and it doesn't take all the cores to do it. Not even close. So I chose virtualization as an option to fully utilize my CPU and my resources. So we're going to turn off the Debian desktop environment and the print server and the SSH server, and we're just going to leave standard system utilities on. That's the only thing, and this will only take probably about 5 minutes to finish its installation. Much faster than the alternative. Okay, so at this point, where it wants to install the grub bootloader, we want to actually go down to continue without a bootloader. This is because by default, grub does not support UEFI. You have to use PC BIOS or MBR, and PC BIOS is a step down from UEFI. You would use a 100 megabyte partition. Don't ask me how they create it, but apparently it breaks standards to do that, and it has to be the first partition on the system, and it's not quite as flexible. So we're going to go to continue without a bootloader. It's going to give us this argument, and it tells us where to find our main partition for when we set the root equals when we manually boot, which will be the next step. And that's why we need the Ubuntu Live CD. So we're going to select that. We're going to hit continue. Be sure you jot down that information. For example, mine is the volume group and the logical volume name. So it was dev mapper, which is the location that those are stored, and it's zen-dom0. So if you named your volume group or anything else differently, you'll have to remember that. This is going to eject the disk for me, and I'm going to pop in our Ubuntu Live CD. The Ubuntu Live CD will have two different boot options, which is why I recommend it. There is a default boot option, but we want to select UEFI, so we're going to press the keys on our keyboard that will allow us to go to boot options, and I'll show you. We actually have two different options from our CD-ROM. One is ACHI and the other says UEFI. We want to select UEFI. And the reason for this is if we do not select UEFI, it will not communicate with the motherboard, and we'll have to take an extra step in order to get EFI installed on the system afterwards. So it'll take us this black screen. I don't know if it still does this in the newer versions. This was, I believe, 12.04, which I think is still the latest out. We're going to press the key letter C, and that'll bring us to the emergency grub menu. Letter C is in cat, by the way. And what we're going to do is we're going to say ls. This operates kind of like a terminal. You'll notice it gives me my disk layout, so I'm going to set root equals hd0, gpt2. It's the second partition, which is our boot partition. So it's in the middle. Would have been gpt2 even if we had created it opposite way around, but you want to remember that. It's the boot partition that we're trying to use. So, and it's on the first hard drive. So we're going to set root equals hd0 gpt2. Then we're going to set linux equal to VML, and then I'm going to hit tab, and this will autocomplete it for me. Now, you'll see some gibberish come out. You can ignore that. It doesn't actually use that for anything, so it won't see it when you hit enter, but we don't want to hit enter just yet. Notice that it's /VM Linus. That's the kernel, but you have to take note of the fact that because this partition is the boot partition, it's just /. If you had not created a separate boot partition, you can still do this, but you need to use the root partition, so /boot/ and then VM Linus. So just a heads up for you. So we're going to set RO and then root equals. I don't really know what RO does, but I know that it's in every example I've ever seen for this. And if you don't remember what root's going to be, just keep in mind it's a dev mapper, and then our volume group, and logical volume name. And then we're going to hit enter, and we need one more line. We're going to set initrd equal to /ini out, autocomplete with tab. I love that. And then we're going to type in boot, and this is the last line. We hit this, and it will manually boot our operating system. And that is how you manually boot Linux. It's 4 lines. It's substantially easier than I thought it would be. So, and there is a little bit of random output. You don't have to worry about that. So we're going to log in as root to start with, and the reason for that is we need to install some packages, and we don't have sudo on there yet. So we're going to do aptitude install, and we want to get grub on there first. So grub EFI AMD 64, and it'll autocomplete for us, just making sure the connection is right. And then we're going to install SSH and sudo. Now I may be using SSH for some of the examples going forward. Simply because I can create video recordings from my main system until we get the GUI installed. My laptop, I mean, not the main system. And then once I get the GUI installed, I'll be recording from the Debian desktop. So, okay, so I want you to note that what this set of packages will do is it will automatically communicate with the motherboard and the BIOS. So we're going to run grub install and update grub, and what this will do is it will create a record called Debian and send it to the BIOS, and then it'll generate our boot thing for us, and that's all set. So now what we're going to do is we're going to do sudo shut, oh wait, no, not sudo, I'm sorry. We want to add our user to sudo too, so we're going to do that, user mod -ag, and we're going to do sudo and then cdlorm. Okay, now the lowercase a and then capital G is to add that group to a user, or technically add, yeah, you're adding a user to a group in that sense, but we want to do -a. The lowercase a tells it to add instead of replace, because by default, if you just do -g, it will replace any of the groups that user is in with just sudo, and that's not what we want. So we're going to hit enter, and if I do id cdlorm is now in the sudo group. Now when you change user groups on your user as you're logged in, you have to log out and log back in for that to take effect at all. So just keep that in mind, because when we add Samba later, that will be relative. So what I'm going to do now is I'm just going to shut down the system and reboot it, and if we did everything right, we should get our grub menu at the restart. And I'm going to eject the Ubuntu DVD so it doesn't attempt to boot from that. And there's our grub menu. And our system is now installed.